In programming terms, the process of of skipping forward to some function is called calling. When you call the function by writing its name and the parentheses, this means that you'd like to jump into that function and start doing whatever is there. The process of finishing a function and going back to where it came from is called returning. When you return from this temporary function where you jumped into and you return back to the function where you were so far until now. But as a matter of fact, returning means something more than just going back to where you came from. Here is something very cool about functions, is that it's not just a list of instructions to do and then finish and come back. As a matter of fact, a function can be an expression, which means a piece of code which yields some sort of value, which means that you can make your call to my function to not only just go there and do some stuff, but you can make it actually yield a value so that you can take advantage of that, for example, and put that value inside of some variable or something like that, or perform even mathematical calculations with the value expressed from the function. That sounds pretty weird. Let's see how exactly this is done. The creation of a function is called declaration, declaring what the function is and how the function works, and also definition, which means defining exactly the details of what the function does. We will see later on exactly a little bit of the difference between declaration and definition, because over here we're doing both at the same time. In the declaration of your function, as we said in last video, you can have a type of variable instead of just void. This type, which you will declare in the creation of the function, will be the type of value which your function can express. So if I made my function not to be void but to be integer, then this means that I can make my function yield a integer expression. So from now on it is valid to use my function and the two parentheses right over here as an integer expression. So I could, as I said, put that in a variable or make some sort of calculation and stuff like that, because now this is considered a integer expression, not just a command to go and do whatever is inside my function. Well, how is this done? How do you return an actual value? Once you declared your function having a type as the variable type of the function, you must have a return statement inside, usually at the end of the function. When you make your function not be void, but you make it to be some sort of variable as its type, that means that this is a function which will be expressing some sort of value, and the compiler must have that value to express, and that is given to the compiler right at the end of the function when you type the return statement. The return statement is the command which tells the compiler what expression to be expressing to whoever called the function. It could be, in this case, if I made it integer, it could be 0 or 1 or 2 or 3, or it could be some sort of integer variable which I might have made somewhere in this function. Of course, it can also be some sort of mathematical calculation, etc., etc. I need to be telling the compiler what exactly is the actual value that it will be returning, that it will be expressing exactly where we called this function. So just to illustrate, let's say we return over here 5, which is now valid because we made this function return an integer. So again, the return has a lot what to do with what we typed at the beginning of the declaration of this function. If we would have made this float, we could have also returned 5 point something else. And if we would have made this character char, so we could return something like a symbol, etc., etc. That's why this thing over here is called the function's return type, because since C++ has strict rules about types of variables, then you must state very clearly what exactly is the type of expression that this function, my function, will be expressing when we use it. So let's say we made this an integer expression and we return the value of 5. Then over here, if I had a variable int x, I could give x whatever will be expressed out of this expression. Well, what is expressed out of this expression? Well, let's see. Let's go to my function. My function, bingo, it does return a integer value. And at this point in time, what is it returning? 5. Well, that would mean that the program, when it bumps into this command over here, it is going to call this function, go and execute whatever it has to do, and finish off by returning 5 as the integer to whoever called it. So right now this piece of code over here is expressing the number 5. So it's pretty neat because it's two birds at one stone. On one hand, you are calling a function, and that function could be doing a whole bunch of neat stuff, like calling other functions and doing a whole bunch of stuff. And at the same time, you get an extra bonus at the end, which is that this function could return some sort of expression, some sort of value, whatever it is you decided that value to be. Now, as I explained in a different video, the assignment operator must match the types of variables, the types of expressions, to be able to do the assignment operation. Here is where we see the strict rules of types in C++, that if I made my function to be Boolean, and that I told it, for example, to return false, and then I try to assign that value false, if it will try to return that false to the assignment operator, which will try to put false into an integer, we might have a type problem right over there, because the function's type is Boolean and the variable x is integer. So this could be a very good compiler error, that the types don't match, and this is a bad piece of code right over here. It happens to be actually in this specific case that a Boolean being assigned to an integer could still work, because false happens to be the same thing as 0, and 0 can be put into an integer variable. So over here we just about get by doing a little bit of assignment operator calculations to see that we could actually somehow figure out a way to assign the return value of my function to x. But in other cases, like we will see in future videos, when you make your own types, if you try to call a function and then grab the expression of that function and put it into some sort of variable which is not matching the type, you will get a compiler error, as we will see. So again, a function that returns a value, which means it isn't void, it has some sort of type as the type specifier, and of course which means it must have a return statement at the end, because without the return word you will get a compiler error. You could take full advantage of that expression and do whatever you'd like with it. You can use the comparison operator to test the expression, the value that comes out of calling my function. So over here, for example, the comparison operator will take whatever comes out of my function, which is returned right over here, and it will compare that with whatever else there is to compare it with, and will decide if this is true or not. Or for example, if your function returns a character, for example, like let's say we will return a character C over here, and since the cout command takes the expression to print out on the screen, you can call my function to get hold of that return value, that character C, to print out on the screen, because again, this is an expression. Whatever is expressed over here, whatever comes out of here, is ready to be grabbed by whoever wants to grab it. And over here we have our insertion operator from cout, which will grab the expression from my function and try to print that out on the screen. Let's see if that works. And there we go. Aside from printing all the other stuff we told it to print, right at the end over here we see the letter C, which is what the cout operation got from the function my function. As we see over here, it returns a character type, which in this case is the letter C.